4.1, Fractional Equations. We're getting close to the end of the book. We've got 3 sections left that I'm asking you to do in Coconuts and Crocodiles. And the first one is really just manipulating fractional equations. That means equations with fractions in them. So it's a little bit tricky and technical, but there's not a lot of new conceptual information coming in here. So you just need to remember a few things. So in the first 2 slides, we're going to be remembering things from Jousting Armadillos. And in the last 2 slides, we'll be looking at equations that have fractions in them and kind of some other ways to solve them. What it's going to do is it's going to help you when you're manipulating different things later in this chapter and then, of course, in the next chapter. So, this is an expression, not an equation, right? Because there's no equal sign. And basically, I'm adding 2 fractional algebraic fractions is what it is. So remember, when you add 2 things together, you need to make sure that you have a common denominator. So you're looking at 77 and 11, and you're saying, what should be the common denominator? And it should be 77. So that means I'm not going to touch my first equation, but I am going to touch my second. Which means I'm going to multiply this by 7 over 7. So what am I really multiplying this fraction by? 7 over 7, which is just 1. So 1 doesn't really change anything, but it will make it look differently and easier to manipulate. So I'm going to rewrite what I've got, 22x squared over 77 plus 28x over 77. Okay, so now I'm going to put those 2 together. And I'm going to say 22x squared plus 28x over 77. Well, guess what? These are unlike terms. X and x squared are not the same, so I can't combine those 2 together. 77 is my denominator. It stays the same. The only thing you could do with this, I think you could leave your answer like this, but you'll learn in the next chapter, or excuse me, not in the next chapter, in the next book, that you could factor out a common factor here. What goes into both 22 and into 28? And the answer is 2. And there's also a common factor of x in both of those. So 2x. And then I'd get 11x, because 2x times 11x is 22x squared, plus 14 over 77. And I'm looking for reducing. So for this chapter and this lesson, either one of these are acceptable answers. Okay? Again, that's just an expression, so it's really just reviewing what you did in Jousting Armadillos. Okay, if I come down here, I have 8 over x plus 2 minus 4 over 3x plus 6. Well, those are not common denominators, and that's what I need in order to really subtract them. So is there something I could do to this one in order to make it say 3x plus 6? Well, if I multiplied both of these numbers by 3, I would get 3x plus 6, right? So why don't I multiply this whole fraction by 3 over 3 so that I don't really do anything to it. I'm just multiplying by a factor of 1, but I'm changing the numbers so that it works better in the problem. So 8 times 3 is 24, and then on the bottom I'll have 3x plus 6 minus 4 over 3x plus 6. Okay, so now I look at my numerator, and I have 24 minus 4, which is just 20, over 3x plus 6. Okay, well, that is an answer. That's all I can do. I could take it a step further, and that's what you'll do in Chuckles the Rocket Dog. You'll say, oh, I see a common factor here. There's a 3. And then if I pull that out, I have x plus 2 left, and then 20 on top. So either one of these would be acceptable answers. My guess is that in this chapter, you're going to probably leave it in these 2 forms. Okay, so one more slide of review. Now I've got 2 multiplication problems. Okay, and this is looking a little ahead, as you've heard me say Chuckles the Rocket Dog several times, because this right here, x plus 3, the way we work with that is a little different than anything you've worked with before. So I have this algebraic fraction and this algebraic fraction, and I'm multiplying. You can look for canceling when you're multiplying, okay? You can look for common factors. Are there any common factors in the numerator and the denominator that I can siphon out? 5 and 2 do not work together. I can't cancel anything out. X minus 3 is a unit, and that's why I highlighted it. It needs to stay together as x minus 3. That's something that you'll explore more again in Chuckles the Rocket Dog. But basically, 3x and x minus 3 look like they have things in common, but they really don't. X minus 3 is its own thing, and 3 times x is its own thing. So all I can do here is multiply the top. 5 times 3x. What is that? 15x. And multiply the bottom. X minus 3 times 2. So I could write 2 times x minus 3, or I could write 15x over 2x minus 6. And that is the best I can do. It feels like I could cancel an x here, but I can't because this minus makes this a whole unit to put together. I would say either one of these are acceptable answers. One last one, that's an expression, and then we'll move on to equations. Here I've got 6x squared, 3x to the third, y to the fifth, and 2y. And I'm pretty sure in this example I wanted it to be division because I wanted to review division. So let's put a division sign in there so I know what I'm after. Okay, and now I'm going to say, all right, I want to divide these. So the first thing I need to do is I need to change it to multiplication and take the reciprocal of my second fraction. Okay, and I did this to make sure that you remembered how to divide fractions because it keeps coming up again and up again and up again, and it'll come up again in the last book. And then I have a new problem. The first fraction stays the same, it becomes multiplication, and I find the reciprocal. Okay, great. Now I want to put I want to multiply across the top and multiply across the bottom, and I can do that. Or I could look for cross-canceling. I do see some y's I could cancel, and some x's I could cancel, and some 3's I could cancel. But before I jump ahead to doing that, let's kind of go the route we did in, well, let's do two different routes. Let's go the route we did up above. 6x squared times 2y squared would give me 12x squared y over 3x to the third, y to the fifth. Okay, but I cannot leave my answer like that because 12 and 3 have a common factor of 3. So that can reduce to give me 4 over 1, just like a regular fraction. X to the second and x to the third. So the x to the second, remember, is x times x. X to the third, remember, is x times x times x. And so I can cancel out this one and this one and this one and this one because x over x equals 1. X over x equals 1. So I'm just crossing out factors of 1. And I'm left with x to the first on the bottom. And then looking at y to the fifth on the bottom and y on top, I can cancel out this y and only one of these y's, leaving me with y to the fourth. So my answer to this problem would be 4 over x y to the fourth. I don't need the one in front. Okay. Another way to do this problem, a way that I like kind of better, if you want my opinion, is I look at 6 and 3, and because one is on top and one is on bottom, doesn't matter if it was in the same fraction or in the other fraction, I can say 3 and 6 both have a common factor of 3. So if I suck out a factor of 3 here, and I suck out a factor of 3 here, all I've done is taken 1 out of that, 3 over 3. X to the second and x to the third, there's going to be 1 x left on the bottom right. Y to the fifth and y here, 1 y goes away, and this becomes y to the fourth. I can't cancel the 2 and the 2, even though it's tempting, but they're both on the top, so they won't cancel out. So I get 2 times 2 gives me 4 on the top, and on the bottom I have only the number I have is 1, but I have x and I have y to the fourth. So I've done the same problem using cross-canceling. Okay, this gets explored again more in the next book, but you'll see it in this lesson. Okay, so now we're going to review some equations, fractional equations. Again, this whole page you saw problems like this in Jousting Armadillos. Okay, so 1/3 times x equals 6. Well, a lot of times people want to divide by 1/3, and that will work. But why not multiply by the reciprocal? Because look what happens. Cancels, and it cancels, and I get x by itself. And if I do that to one side of an equation, I have to do that to the other side of the equation. I'm not going to use a fraction because 6 isn't a fraction, so I'm just going to use the number 3. And I get x equals 18. If I had divided, it would have given me the same answer, but a little bit longer of a process. This one here, I could multiply both sides by 3, just like I did here. In fact, this is the same problem as this, but I wanted to show you another way to do it. Notice the 1/3, you're missing the 1. Well, the 1 is right here. It's kind of hidden. 1/3 x equals 6, or 6 over 1. Same problem. Okay, so if I saw this, I might approach it a different way. Remember, you learned how to cross multiply in jousting armadillos. So why don't we do that here? Whenever you have a fraction equal to another fraction, you can cross multiply. So I get x times 1 equals 6 times 3. That means x equals 18. Whew, that was easy. I also see a fraction equal to another fraction here. So let's cross multiply. This one's a little harder. I get 4 times 4x plus 4 equals 8 times 4x plus 1. And I get 16x plus 16 equals 32x plus 8. Subtract 16x on both sides. I'm actually going to subtract 8 on both sides all at the same time. Look what happens. Gone. 8. This gives me 16x, and this goes away. Divide by 16, and I get x equals 1/2. Done. Kind of fun. Kind of fun. Okay, I think those are all review, but they're harder reviews, so maybe you needed another brush up. Now, this is where the brand new stuff comes in. Last slide. 2 more problems. This looks pretty complicated. So you have 2 choices here, and you can decide which way you want to do it. You can either make these all a common denominator, okay? And if you make them all a common denominator, then you can add them together. So let's do that. If I made this tenths, that means I would have to multiply this fraction by 2 over 2, because that would give me 10 on the bottom, and on the top it would give me 2x minus 10 if I distributed. Plus, now I want this one to turn into 10 on the bottom, so I'm going to multiply this one by 5 over 5, which gives me 5x plus 35 over 10. This one already has tenths. Okay? Now, because everything is tenths, what if I just multiplied the whole thing by 10? That means I multiply this by 10, this by 10, and this by 10. Well, you know what would happen? All those tenths would go away, and I would have 2x minus 10 plus 5x plus 35 equals 2x. Because if I multiplied 10 by this fraction, the tenths would go away and I'd get 2x. If I multiplied 10 by this fraction, the tens would go away and I'd just get this. If I multiplied 10 by this fraction, because I have to give 10 to everything, I would also have the 10 cancel and I'd have 2x minus 10. Okay, let's combine like terms. I'm running out of room. We get 7x plus 25 equals 2x. Subtract 7x on both sides. I get 25 equals negative 5x. Divide by negative 5 on both sides. X equals negative 5. Now that was a tough one. And I think you'll find this exact problem in the lesson. Okay, let's do another one. There are other ways to do these too. So when you see one like this is very similar to the one you just did, believe it or not. Let's see, it's not exactly the same though, I don't believe. No. So when you're doing one like this, I'm going to change the color so we don't get mixed up. Basically, I've got fractions and I've got whole numbers. So why not make everything a fraction? It might be easier to work with. Okay? Now look at the denominator and say to yourself, what number does 1, 2, and 5 go into? Well, they all go into 10 because I just used that up here. So why not multiply everything by 10? Everything. If I do everything by 10, I haven't changed the problem, I've just built it up times 10 greater. So if I multiply 10 times 3x, I'm going to get 30x. If I multiply 1/2 by 10, the 2 becomes a 1, the 10 becomes a 5, and I basically get 5. No more fraction. If I multiply 10 times 4x, I get 40x. And if I multiply 11/5 times 10, I would get 22. Now I've taken this kind of crazy looking thing. I'm going to make that look like a better 3. I've taken like a crazy fractional looking equation and I've made it into something that's just a regular equation. So it feels much better in this form than it did in this form. Now, I could have made common denominators and combined like terms and added fractions and cross-multiplied. That would have also gotten me the right answer. So you have lots of choice, but you're basically just manipulating complicated equations in this unit, in this lesson. So that cancels. I get negative 27 equals 10x. Divide by 10. X equals negative 2.7. And I'm done. Okay, well, that's complicated. Good luck. Ask questions if you have them. Chapter 4 in this book is a little bit tricky. So ask questions, get lots of practice, and make sure you're understanding what you're doing.